gentlemen, welcome to the second session of the second day of 5G India 2021. The session is going to be 5G infrastructure and future business models. And this session will be moderated by none other than the industry veteran, Colonel Vikram Tiwatia, who's the Deputy Director General COI, who doesn't need any introduction. Everyone knows him, but still just to the new generation who has joined the fraternity, we have 700 plus attending this event. There are few who has, Colonel Sir, exactly 732 is there online attending the event. So just to say that, he's the Deputy Director General of COI, working for the last so many years in the industry, working closely with all the officials of DOT, MIT and TRI. And he's also the member in the Cybersecurity Council, which is chaired by the Chief Cybersecurity Coordinator. He also the member of various associations like CI, FICCI, SHM, etc. He serves as the board of the Global Certification Forum, which is known as GCF. Colonel Saab, over to you.
Thank you so much, Sashi. As always, it's a pleasure to be on platforms of Bharat Exhibition, and compliments to you and your team, given the challenging, business environment, particularly in this online format for an events management company. I'm sure, you're looking at better days ahead.
Thank you so much.
Compliments to you. And a warm welcome to all the participants. I'm told there are about 370 folks who have joined this very interesting session. So welcome to everybody. And I'm sure that you will, benefit from this really eminent panel that we have with us today. So we have Mr. Shamik Mishra, who is the Vice President and CTO Connectivity at Capgemini. Now, Shamik is, he was earlier Vice President for Research and Innovation and Global Chief Industry Architect for Altran. And of course, the good thing that I notice is he's been elected as the Deputy Chairman for GSMA's Operator Group. So welcome, Shamik. Thanks for joining us today. And then we have a very eminent Professor Kiran Kuchi, who leads a lot of standardization efforts, and we've been working together. So he's currently at IIT Hyderabad, and he's also very active in the TSDSI and 3GPP platforms. And recently, he has incubated a startup company, YSIG Networks, at IIT Hyderabad, which he has just found. And of course, he is a regular at the 3GPP and TSDSI efforts, and also has contributed about 100 plus, proposals at 3GPP, and has got numerous patents in India as well as in the US. So welcome, Professor Kuchi. And we have now also Mr. Sumit Pillai. So Sumit, how are you doing? Great, thanks for joining. So he is from Vyas 3D India, and he would be presenting on developing reliable 5G products with, electromagnetic simulation. So wireless is the way to go, and I'm sure, he's mastered all the simulation parts of, using different bands of the electromagnetic spectrum. So welcome, Sumit. And we have Mr. Samik Biswas, who is head of marketing at Plintron India. He's from IIM and Purdue, with more than 25 years of experience working across continents. Wow, super. And with the operators, Reliance, Tata, Globacom, Nigeria, SR, and so many IT companies. He's been a pioneer of digital marketing in India and in Africa, and has a wide experience in monetizing new technologies in Asia and Africa. He's currently head of marketing at Plintron, the world's largest MVMNA operator, and which has subscribers in 6 continents. With that, I personally am also looking forward to the presentations by this panel. A couple of words, I'm sure earlier they were said, but the good news part is that in the recent years, particularly since 2016, the pace at which the Indian telecom network has grown has been phenomenal. In fact, if there is one sector which is actually empowered individuals to be able to, do so many new things, it is this telecom and broadband sector. So the combination of the smartphone, the internet, and the banks and the KYC, right? This combination put into the Ninja tool, which is the mobile device. India has done some real global best practices, which in fact, Sundar Pichai actually recommended to President Trump. Hey, how about in the US, you follow India's example of the UPI, the NPCI UPI combination. It's so convenient to send money, right? And then what we've seen recently is this, how do you view transportation for that matter, right? Earlier, you had to own a car. Now, youngsters who are on this call, my advice, you don't need to buy a car anymore, right? Because you have a car at your beck and call, and a car of your choosing. Why get held down by one vehicle of a Honda or something? You decide which car you want to ride in that day for that period, and you can, order that. So just yesterday, one of my colleagues in this lockdown period, so normally e-commerce, right? You're getting tomatoes delivered at home. You're getting your pizza delivery. Here was a car delivery to your home. Okay. Now, this is the power or the enabling factor, which is a kind of, providing service to individual citizens. Your GST would not have happened in India if you did not have a broadband network. Your FASTag, right? Convenience. So there are multiple applications. And given that we are on, 5G is on the anvil, with DOT having recommended spectrum bands to TRAI. So the journey for 5G has actually, started in earnest now. And possibly we've been a trifle late. But the good part of being late is you always benefit from a developed ecosystem of which has been tried, tested in other geographies. So India will gain from that part, right? Now, with these initial words, I will now request Mr. Shamik Mishra to go ahead and make his presentation. Over to you, Shamik.
Thank you, Colonel Tewatia. This is a great pleasure to be here with such an eminent panel. And thank you for inviting me as well. So I will quickly share my screen in a moment. I hope you can see my screen now. Okay, so I'll just wait for 5 seconds with everyone being able to see it. Okay, thank you. So thank you for this great introduction. And so I am from Capgemini, and we are working in the 5G and in the edge computing space for over several years now. We have been in the forefront of developing 5G capabilities globally, whether it's helping our customers develop 5G chipsets to 5G networks, software to system integration, to right up to developing use cases for industries. And today, in the next 10-15 minutes, what I'll cover are some of our experiences about leveraging 5G to build new experiences for industries. End of the day, a technology like 5G have to have a consumption model. We all know that any technology's success depends on how we consume the technology. If you go back and look at the history of wireless telecommunications, initially when data came to our phones, we actually didn't know how to consume the data. Then, of course, the innovation happened. The innovation happened outside the telecommunication industry, where companies like Apple and Android and others developed the application ecosystem. We suddenly knew how to consume internet on our phones, and new kinds of applications, new kinds of digital ecosystems got built. Fast forward that to 4G, when the data became more reliable, the internet connection became more reliable, as Colonel Tewatia was talking about. New kinds of businesses got developed outside the telecommunication industry. So whether it's calling a car or ordering a pizza, or more importantly, in India, the fact that many of us use digital money today, UPI and other kind of payment systems, that is only possible because the reliable network that we get today on our mobile phones. So consumption models are extremely important for any technology to succeed, and 5G will be no different. But perhaps the only difference in 5G and with 4G would be that that we would be interacting more with machines, and machines would be interacting with machines more often than not in a more connected manner. Of course, the consumer experience will continue to improve. We expect to download Netflix movies in seconds, perhaps, but at the same time, the industrial change is going to be massive, and that's what I'll be talking about today. But at the same time, we are witnessing a massive transformation towards connected products. I mean, products which were not connected earlier. Now we can build new kinds of use cases, new kinds of experiences, new kinds of business model by just connecting products. Say, for example, a printer or an MRI machine, or a transportation segment like, say, a train. Maybe new kinds of businesses and business models can now be created by just connecting such devices, lack of a better term, to the internet. And this is possible because 5G, not just 4G, but 5G as well, promises seamless connectivity and unobtrusive connectivity to such devices. This has also given rise to the fact that there is a massive increase in the need of immersive experiences, whether it is in the entertainment segment or even in the industrial segment. We are actually working in several projects as we speak, where we are helping industrial customers use augmented reality to improve productivity on the shop floor in a manufacturing context, for example. And this is a massive industry. The augmented reality or the virtual reality use cases always depends on a device which has to be worn. And you can see in this picture, the lady here is wearing quite a heavy contraption there. Because we have to pack an entire computing power inside those devices. So devices at times gets heated up, the performance can dip, and the fact that it's extremely expensive because the whole computer is packed inside that device. Now, if we can move some of the compute outside the devices to an edge compute or a nearby computing device, we can actually reduce the price, we can give better experiences, but for that, we will need a very solid connectivity between the device and the compute. So that is what 5G is enabling, a completely new experiences, but at the same time, it's also creating new business models around it. And then, of course, the question of manufacturing and in the shop floors, or whether it's in the transportation segment, whether it is in the automotive or even in aerospace, we see devices, robots, sensors, assembly lines, all getting connected. And they are benefiting from different kinds of technologies like computer vision. So, for example, we were recently working on a project where in an assembly line, through computer vision, we are trying to detect a faulty package. Now, that can be done in different ways, but if you can have a properly trained computer vision algorithm, we can detect a faulty package in the assembly line itself. And we can stream those videos to a compute far away or maybe nearby, where we can run those algorithms. So combining AI, edge compute, and computer vision and connectivity, like 5G, new kinds of experiences are getting developed, delivered, improving the productivity of manufacturing as well as an industrial context. And all of this is possible not just because the technology has arrived. It is also because that there is a radical change and transformation in how we store information, how we manage information, how we compute information, with the emergence of software-defined networks, with compute becoming more agile through containerization, with the fact that the whole IT infrastructure is changing dramatically. We are able to bring all of this together today: edge computing, 5G, advanced connectivity, transformed IT infrastructure, new kinds of business models, creative thinking, and bring all of this together to build a new kind of business for our customers. And we are seeing a lot of opportunities around this, whether it's advanced digitization and automation in the areas of automated operations, automated machines, even in control towers, in track and trace, indoor and outdoor geolocation. We can actually pinpoint today a device in a massive shop floor to the scale of centimeters, because the technology is there today within an indoor context through 5G. We are also seeing new revenues. Car makers are looking at creating new revenues beyond by selling the car. I mean, if you look traditionally, if I'm a car seller, I sell a car, I more or less 80% or 90% of my revenue that I can get out of that car is realized at that point itself. There's nothing really a car maker can make beyond that. But with 5G and with the fact that new services can be delivered out of cloud, there could be new experiences, new maps, new navigation, new in-vehicle infotainment, new kinds of games that can be pushed into the vehicle from a distant location today. So there is a possibility of car companies or automotive companies to continue to build on the revenue for an asset they may have sold, which is not the case today. So it's most of the vehicle makers make maximum revenue out of the first time they sell the car itself. We are also looking at warehouses, and the pandemic has in fact accelerated that. That people cannot travel so much into the warehouses. How do we actually automate the warehouses? How do we automate logistics? How do we interconnect, say trucks that is carrying massive amount of material from point A to point B? How can we make factories more smarter? So all of that is possible, driven through the fact that the infrastructure TCO is going down. And this entire paradigm shift means that the communication service provider or the telecommunication providers and the industry verticals can collaborate to deliver a complete new shift towards digitalization and towards automation in different industry verticals. And just to summarize what I just spoke about, if you look back and see how things have evolved over the past several years or decades. We started in the PC era where there was very little interactive content. There was virtually no autonomy in that space. With higher speed and higher latency, with the advent of 4G and the advent of smartphones, we found higher speeds. We now experience lower latencies, and a little bit of more autonomous experiences have started to come up. With the next generation devices, it completely leverages on the fact that there is high speed available on the internet or on the connectivity. The experiences demand lower latencies. These are new kinds of devices which hitherto were not connected. Some of them were, some of them are getting better connectivity access. And this particular area is what we call as edge native, because it's more closer to the point of action rather than far away on the cloud. And this space is getting even more interesting because the use of artificial intelligence, use of data, use of intelligence and cognitive capabilities are delivering the promise that these devices were initially focused on. And we did a survey. So we did a survey, and as part of Capgemini Research Institute, we interviewed over 1,000 executives across different industrial organizations and over 150 senior executives from telecommunication organizations as well, and globally, not just in India, globally. And this was done earlier this year. And we were surprised, not really surprised, but we were delighted to understand that over 60% of the industries are looking to adopt 5G. Most industrial companies are looking to adopt 5G to reduce their overall cost, increase automation, and improve productivity. And 40% of them are actually going to launch a site or two in the next year or so. And then there were 60% of them are also looking at models where 5G can enable new business models for them, new revenues, not just reduction of cost, improved productivity, but also new kinds of services. And this gives rise to a very simple model that we were thinking on how all of this can come together. We have the devices, we have the edge, we have the cloud. There is data that is flowing between the devices and the cloud. And then there are applications and experiences that I was talking about that can be built either on the device, on the edge, or on the cloud itself. And if this is all about convergence of data and connectivity and hosted on edge and cloud. So the data, once it gets transferred from a device to an edge, we can build new kinds of applications which can crunch this data. It can lead to efficient operations. It can lead to new kinds of more insight-driven, better, efficient control over business processes. And also it can build or it can offer new kinds of services to the customer of our customers, who can then build these businesses and we can deliver these businesses out of cloud, which perhaps was not really possible unless these devices, which are primarily machines, are able to connect to service hosts like cloud and edge. And this is what we call as intelligent industry, because we are leveraging the power of data and cloud along with connectivity. We are converging all of this. And this is resulting in intelligent products, design and engineering, and it's also helping in developing new intelligent operations. We are able to now perhaps make factories smarter and a supply chain smarter and provide intelligent support and services through digital continuity. And let's take some examples. All of this sounds a little futuristic unless we really take some examples. These are some of the pictures that you see which are delivered from, some of them are actually live projects. The one on the top that you see, a mobile robot, this was built in Spain for an airport, where this funny looking contraption, which is a robot, actually has thermographic cameras. The thermographic cameras can actually check people without masks. It can also check people body temperatures. It can relay this information to over a 5G connectivity provided by a telecom operator, and from an edge compute, the edge compute can notify airport authorities or real estate authorities about a certain situation, and they can keep the surveillance on during an event or during, say, for example, in a place like an airport. The 5G mobile clinic that you see, this was one of the projects that we actually did in Italy, in a city there, with the city municipality, of how we can connect a first responder network on an ambulance over a 5G connection, where in an emergency condition, a remote doctor can actually provide direct consulting to the local paramedics through telemedicine technologies, primarily driven over 5G. And then the bottom picture that you see, this is about creating service and maintenance augmented reality for in factories, where through augmented reality in the factory floor, technicians can be instructed by a remote expert on how to handle a certain situation. And this is quite interesting because we have seen now aircraft companies are actually leveraging this kind of technologies to ensure that that aircrafts are ready for a takeoff after it has done a trip. So when a plane lands in an airport, it has to go for the next trip and it needs to do certain checks there, and a certain amount of maintenance process can actually be automated remotely. I mean, these are all in proof of concept stages now, but some of them are becoming real world. We are also building and working on several augmented AD or autonomous driving projects globally. The one that you see on the bottom are two of the projects that we are doing in Spain. It's called Remotes. This actually is, the effort is to provide multimodal transport for the last mile connectivity. For example, in an airport, if you want to have autonomous shuttle from a gate A21 to B36, certain things can be done without having to have too much risk involved in it. Or, for example, in mining or in hazardous locations, managing a vehicle there can actually be done remotely, like a crane or a bulldozer. Those can be actually managed remotely by through an edge compute over a 5G connectivity. We also launched our own autonomous vehicle R&D program. It's a research and development program. We have that project is called Samriddhi. You can see the first prototype of the solution there on the top of it. This is currently in Capgemini Bangalore, where we are trying to build the algorithms, build the safety first functions for level 4 ADAS, as well as we are looking on how we can connect all of the autonomous vehicles to and convert it not just to an autonomous vehicle, but also to a connected car. And there are early trials happening on connected car, which we are part of, including in North America and Europe. And very soon, I'm sure this would such projects, such investments like Samriddhi will bring such technologies to India as well. We are also working in warehouse automation. This is an example that we did with a UK-based retailer. Here, stuff had to be moved from point A to point B. People had to move it. People couldn't travel because of the pandemic. So we had to design a new kind of robots which can move stuff from point A to point B. This had to be developed on top of a new radio technology. We also had to ensure that the robots don't collide with each other, so they had to be fairly autonomous. We had to ensure that they don't create enough noise in the network. So the entire private cellular network, which was driving this, had to be redesigned because of the dense nature of the use case. There were 1,000 robots in this warehouse, so there was a massive number of devices which are interacting and navigating the entire shop floor. So it's or entire warehouse floor, which required fairly different kind of an R&D approach to solve that problem. Also, we are seeing a use of 5G in media and entertainment. This is a work that we did with an operator in Italy for Sky TV. This was for the music reality show X Factor. In this particular case, the singer was in a different location, I think in Germany, and the band was somewhere in Italy. And the hologram of the singer had to be holoported. It was done entirely over a back-to-back 5G network. This was quite critical to have low latency, because you possibly cannot have a scenario where the singer and the music band are in complete different time zone or in time spatial points, and it would sound horrible if the music and the song is not synchronized. So we realized the importance of low latency connectivity and how codecs can actually be transmitted over a 5G network, or a decompressed and compressed codecs can be done. So it was a wonderful experience for us. We are also building sustainable technologies, like, for example, the project that we're doing called EcoSat, which is a high altitude platform and airship, which can provide connectivity to remote locations, and it can also help in mapping and connectivity of remote locations. This is completely based on, it's a zero polluting emission device. It is it's not exactly a satellite that it would go outside the atmosphere, but it's a high altitude platform providing Earth observation, connectivity technologies, and it can deliver even 5G connectivity to remote locations. And this is an early prototype that we're working with a couple of partners. Apart from that, intelligent automation that we have been working on is, for example, in case of rescue UAV, these are drones connected to 5G network. There are predictive maintenance use cases that we are building for autonomous factories or smart factories. We are also able to foster improved productivity through using different kinds of technologies. All of these are convergence of technologies, and that's what we really are talking about here. AI was developed for some separately, 5G was developed separately, cloud technologies were developed separately, but we bring and converge all of these technologies together. We get these kind of very interesting use cases, which are completely transforming the industry towards more intelligent industrial experiences. So with that, I'll come to a close. Just a word perhaps at the end that devices, people, smart homes, smart offices are going to generate massive amount of data. This data has to be transmitted over a network, and 5G is going to deliver the promise. When these data are analyzed and new experiences can be brought in, primarily for private networks in a secured, privacy-first environment, for infrastructure, for telecommunication companies, for industrial companies, we are looking at a massive opportunity in front of us, which, as in India, we can develop and drive some real modernization and transformation technologies for the community. And that's what we all are here today to think through this. Thank you very much for giving me this opportunity.
Hey, hi, Shamik. I think this was just marvelous. I think, the kind of work that you're doing in so many other places where 5G is already commercial, right? So the good part is that, in India, let's say we have about 22 lakh base stations today. These are in network terms located on about 6,70,000 physical sites. Now, of which 75% is 4G. So,
Yeah.
All these are because they are new base stations predominantly, mostly post 2016. So they can be upgraded in NSA mode for the 5G depending on the enterprise demands that come up, right? So, and then the good news again that I see is, when we see the infrastructure at the new airports at Bombay, Hyderabad, and Chennai, and the government's announcements of so many more private players who are going to be building up these airports, plus private airlines as part of the UDAN scheme, just as one example. So the potential to enhance the efficiency of all such work. In fact, another favorite of mine is India, the second largest producer of milk in the world. And much, even fresh produce like fruits and vegetables. But a lot of it goes waste because of a lack of a cold chain or from the farm to the fork. And in engineering terms, I'm sure Kiran teaches his students day in, day out. As an engineer, we love our efficiency. Eta is equal to output by input, right? So what you have done in so many parts is the ability of 5G or digitization to make that data sweat for you to reduce the input.
Exactly.
And therefore the national efficiency can go up. Yes, Kiran. So we'll be happy to hear, how you can facilitate, or your thoughts on enhancing national efficiency, and there also more sustainability in your address. Over to you, Kiran, and thanks to you, Shamik.
Thank you.
Professor Kiran, you are on mute.
Thank you. Can you hear me?
Yeah, Kiran, we can hear you.
Yeah, okay. Okay, so I'm talking about R&D, but I'll be happy to address what Vikram was talking about. We have some solution, hopefully. It addresses, if not the full problem, but maybe part. I'll first summarize what we have done and what we intend to do.
Kiran, just who is handling the slide? If you could put it in presentation mode, that'll be helpful.
Yeah, just read it. Yeah. Is it fine?
Not yet. If you could put it, yes, that's fine. Please go ahead.
Yeah. So I'm just doing a quick summary of what we have done in the last several years. Thankfully, the ministries have funded us for the past 10 years. I have been able to set up a very large 5G development team, driving standards, developing intellectual property, and now we are building products. That's the phase we are in. So we did, we did try to make some impact on the 5G standards development. Massive MIMO and this waveform that we have developed that hopefully will find utility in the networks very soon. We developed a lot of patents over these years. Some of them have gone into 5G specifications. I have been driving a small team in 3GPP, lots of contributions since 2015, 5G new radio standards development as well as NB-IoT standards development. So now the last 4 bullets is what we are focusing on. Whatever I said on the first 3-4 bullets is the work already completed. We started a company some 4 years ago in our IIT Hyderabad Technology Incubator. We're a small size in an outfit, building solutions for help the existing vendors. We have a 5G base station and UE. We have developed subsystems which are already being commercialized now. Mostly, building physical layer and protocol stacks. So we are already generating revenues. We also have done one project. It's on narrowband IoT. This is different from IPs. We have developed a production grade chip. We expect to go into production in a year. I'll show you some samples and this chip. We got started on 6G research about a year ago. We're already tackling the convergence between satellites and 5G. We're developing solutions around NB-IoT and 5G. So I think last night or a day ago, the Prime Minister, in a discussion with Qualcomm CEO, I think he made a statement. I just kind of copied it from the newspapers. So I think there is an awareness at the national level that 5G is important. We have to develop the fundamental technology. Now, of course, finally, we have to use it as a consumer. So we have all these three aspects to be covered. But I can only talk about developing the technology as opposed to the services. So there is some interesting thing we have done just, I think, 2-3 months ago. There is one new base station that we developed. It increases the efficiency of the radio channel. Every bit that we transmit, it costs us money because we have to license the spectrum. So in this experiment, we have transmitted 36. We have served 36 users at the same time in the same time frequency slot. And I think we achieved like 24-fold increase in radio capacity in this very megabit base station. What it means, I think it will take another 5-10 years before some new architectures will emerge. We're just trying to push the envelope of the so-called massive MIMO. We did the first demonstration in 2007. At the time, we demonstrated 12 layers. And we commercialized this 12-layer technology with some vendors. Now we kind of push this to the limits. Hopefully, it will be part of 6G or 5G advanced. So we're looking at what is the best we can do in this space. We also demonstrated a few years ago something called a cell-free massive MIMO. Basically, we distributed a lot of cell sites in our campus. You can see these small cells, and we connected them by fiber to a cloud. And we do this so-called cloud processing, and we ensured that every user receives the signals free of interference from the neighbor. So this used to be called Cloud RAN, then it became XRAN, and then it became ORAN. It went through a different evolution. We did this experiment in 2016. I think this is being talked about as a candidate for 6G. So I'm just showing you these real systems that we built, developed, and demonstrated. This is again the work done like 5-6 years ago. Let me move ahead to what I'm doing right now. So this slide summarizes what I am doing right now in terms of delivering full-fledged products. 5G, G-Node B and UV, we have developed 2 base stations. One that works with an Xilinx FPGA as an integrated base station by itself. And another solution we developed based on an AMD server and Xilinx FPGA. And this base station has an inherent support for massive MIMO technology that I just talked about. In the labs, we achieved, I think, around 9 Gbps or 10 Gbps with this 5G base station. So soon we'll start deploying this and start conducting experiments. And we're partnering with various chipset vendors to commercialize this technology. On the UV space, we already have licensed our technology to some customers, both physical layer and protocol stacks, including sub-6 and millimeter layer. So essentially, we're building the technology building blocks of 5G and commercializing it and growing up the ladder, with deep tech ownership. So we got a chip taped out on narrowband IoT early in this year. We started testing it. It's fairly successful. We intend to take this to production next year, maybe perhaps the end of next year. So I can talk about, what could you do for cold storage and chains, maybe using this chip. The government is very keen on this kind of semiconductor, devices. This is something I think the Prime Minister was also talking about it yesterday in his trip to US. I'll skip these technical details. This is a ORAN-based distribution unit that we developed. This is the one I was talking about, AMD plus Xilinx. This includes a massive MIMO as part of this solution. And this DU, we have a working physical layer that we support chipset vendors and chipset providers and base station manufacturers, who don't have this technology. We provide the deep know-how and we license these IPs. We've done this already for LTE massive MIMO already with one particular customer. So I also touched upon what we intend to do in 6G. One particular project the government has funded us recently is convergence between satellites and 5G. So what we are doing is we have taken the 5G stacks that we developed and we're upgrading them to support satellite connectivity. We already done that with narrowband IoT on a chip. we'll probably be testing this with a geo constellation later this year. And we intend to do that with LEO and other constellations for broadband communications, fairly soon. So I will touch upon this application part that's being mentioned. Right now, I am targeting this chip that we are producing for energy meters right now. That seems to be a use case that has been very clearly identified. So I'm working on this use case, energy meters. The chip that we developed has a GPS NAVIC built as part of this. So we intend to deploy this for asset tracking, especially for low bit rate applications. So this cold storage, checking the parameters of the agricultural produce, tracking the health of this produce, definitely a very, very important application. So what I call perishable goods management is extremely important for India. Agriculture, I'm pretty sure there are lots of applications that and tracking of assets, whether it is railways or commercial applications. There are quite a lot that could be done. I think this is still an evolving technology in India. I think, but it will really take off in the next few years. So we want to deploy this chip to address some of these verticals. You can see the physical form factor of the chip, fairly small, less than 10 square mm. And it has the NB-IoT complete SoC. It's probably the first time an SoC is ever built in India of this kind, cellular technology. It has GPS constellation in it, the family of GPS constellations, so you can use it for tracking. The actual form factor of this device will be, other than the SoC, you will need a power amplifier externally and a SIM card and a battery and an antenna. So you can basically put this in the form of like a postal stamp. That will be the form factor eventually. So that's what we have now. You can see the inside cut of the SoC, the footprint. The left side is analog section, right side is the digital section. And you can see the chip on an evaluation board. This is a very bulky board, not necessarily the full form factor product. This is an exercise that we did as part of the chip bring up. You can see the uplink signal being transmitted. This is a 200 kilohertz channel. We'll soon be taking this to operator trials. This technology. So I'll stop here. We think that we have a lot to contribute. We'll continue to do this work. 5G base stations, UV, physical layer stacks, narrowband average chip, moving to 6G. And I'm also planning to do some application development around the chip that we have done. So that will probably something I'll focus in the next year or two. With this, thank you very much. I'll stop here.
Hey, hi, Kiran. So thank you so much. As always, it's always a pleasure to see the tremendous good work being done by you and your team at IIT Hyderabad, and also the great collaboration with all the other academic institutions. So this is good stuff for the Indian, IPR and potential for manufacturing and licensed products in India. So thank you so much. This is, I'm sure that all the folks on who heard this would be happy to hear the great efforts and, technical superiority and knowledge base that we have within our institutions, which can be substantially adding value to the networks in India. So thanks, Kiran.
Yeah, thank you, Vikram. If you can excuse me, I have to jump to 2 other meetings. So if you can kind enough to excuse me, may I take leave?
Sure, go ahead, and all the best for your meetings.
Yeah, thank you.
All right. Hope to see you in Hyderabad soon. Yeah.
Yes. Please visit.
Okay. All right, folks. We have with us Sumit Pillai. So Sumit is from EMAG and YS 3D. And Sumit, as I had mentioned earlier, he's going to be talking about developing reliable 5G products with electromagnetic simulation. So over to you, Sumit. You know, one of the things that I find very often is there's so much emphasis on wireless, whereas there is a heavy dependence on the wireline component in a 5G network. So particularly, you know, maybe Shashi, if sometime you're going to pick up, talking wireline in 5G networks and their impact. So that could be a potential topic. But over to you, Sumit, for the electromagnetic simulation part.
Thank you, Colonel sir.
Yeah, thank you very much, sir. And I agree with you. There are so many talks will be happening about the wireless network, but yeah, but I have seen that I'm interacting with so many 5G players in India and abroad. So I have seen that it's not only wireless, there are so many other aspects also coming in. Anyway, I'm going to present something about how we can accelerate the growth in the industries using the electromagnetic simulation, because that is one of the key aspects for the 5G development, not only 5G, any kind of technological development. I'm going to share my screen. I hope you can see me right now. Yeah. Is it visible? Yeah. So today, what we are going, anyway, we have seen that so many good lectures is coming out, and everybody is talking about the development is happening in India. I'm very much happy to see that there are so many, we are going to be a big player in the market and the global market. So to adding that, to give more confidence to the industries as well as the academics, I just want to present you that how we can contribute, or how the computational electromagnetics can contribute to the different industries in terms of the fast development. One thing is fast development, second one is the error-free development, and third one is how to combine with international standards. Whatever the product we are going to manufacture, then definitely that should be compliant with international standards, or whatever the standards which will be developed by the 5G, 3GPP standards. So what we are going to talk about is current challenges. Obviously, you may be already familiar with these challenges and the solutions, but I will be a little bit talking about the electromagnetic aspect, how we can able to solve this kind of problems. So like on my previous Professor Kiran sir was saying, and Mr. Sir was saying about the smart cities, smart development. So that is one of the innovation what is happening in around the globe. Connected home, we are hearing it about some around 10-12 years back. Now it is coming to be completely on the wireless, and you have a latest version of the mobile phone. You can control everything in your home. And not only that, now the vehicle and now the latest vehicle are coming with not the keyless entry systems, and you can even operate your car with a mobile phone that you are seeing in the fictional movies in the past. So that is a kind of development is actually happening. But when it is happening, one of the key important role is played by the connectivity materials, especially the antennas. That is one of the thing, and the drivers, which is actually controlling the antenna. So basically, the antenna is just a transducer. So there are so many systems are behind it, how to get the reliable communication. And about the 5G, the reliable communication is one of the most important thing, the data rate, how much data it can be transmitted, how error-free the data is coming, and also the multipath propagation that is also taking care of it. So it is all coming into reality. You will get a good product that is can manage, that will be error-free, that is can withstand a huge amount of data. So that is one of the most challenges that is happening in the industries. So what the simulation is playing a role, I hope that all the folks who are talking about, they will be also have some firm with the simulation methodologies, because simulation is one of the important things. The reason is, if you go for the calculations, you go for the manufacturing and you manufacture it, then you see that, okay, it does not comply to the industrial international market or international standards. Then again, you have to go back to the manufacturing. It is adding a lot of cost, and the development time will be increasing. And now you see that is a very highly competitive field. Everybody is coming up, every industries are coming up, and everybody want to sell the product, or they want to come into the market first. So first in, first out methodology. So one of the most important thing to accelerate this process is the simulation. The simulation will give you an idea that whether your design process is going to be working or whether it can be complained or what are the kind of challenges is going to happen in the real time. So that is what generally does when the last couple of years, and there is a good improvement is happening. The simulation from 80% to 90%, some of the simulations are giving very good correlation with the measurement as well. When you come to the electromagnetics, we will be focusing on the 4 different aspects. One is the basic microwave and optical region, where a lot of players in India as well, they are working on the antenna arrays for the base station as well as the receiver part, and also they are also working on the fiber material optical transmissions. And again, I will say, as I mentioned before, that the PC based, the ECU boards are one of the most important things, but they are suspected with a lot of emissions, radiations, immunity problems are there. That also we had to take care of. And now I can see that the switching networks, that is also one of the thing, actuators, controllers, and now you can see that all the industries are moving towards electric vehicles, the electric motor design, and it's also one of the complicated thing. So, but everything will be in a single hand that can be done by the simulation portfolio, and they will be all connected together. So you get like a system and assembly modeling. I say that everything can be connected. You can understand the how the performance is happening. If the antenna is radiating and you are getting the some what will be the fluctuations happening on the cable, because the cable also gets susceptible with the external radiation. So that all the kind of analysis can be done in a single nutshell. Now, now you see that the features about the 5G, as you see that one of the thing is it should have a very good latency, and there should not be any delay in the response. You have to send a bulk amount of data that should not be, delayed. And like Mr. Sir was presenting about the that kind of events, virtual events, where you can place the singer can be one place and the background can be another place. So one of the thing is no latency, the speed of the transmission. There is no delay should be there, and you should have transmitted a huge amount of data. So everything will be important in terms of the 5G. Now, these are the statistics what you have seen in from the past. Now, even it is forecasted from a couple of years back, but now I think that it is again improved. So 25 billion is now maybe improved to 51. That is a kind of forecast already there. So we have more than 50,000 of technical purpose on 5G is already released, or it is coming on the way. At least 30,000 is already in the market, already in the different journals and conference papers. Now, one of the thing which is also need to be discussed is about the frequency bands, like Kiran sir was saying about the different kind of frequency bands he is actually going to test. So we will be interested in the sub-6 gigahertz frequency band as well as the millimeter wave frequency bands. I think that in if I remember, Samir Chennai, they already have a test bed for the sub-6 gigahertz 5G test bed. So these are the development is also happening in India, not only just for the developing of the communication devices, they are also developing the different kind of test beds in the incubators or the IIT kind of prestigious organizations, institutions. Now, coming to the different challenges in the industry and how we can solve that is the part will be coming. So one of the thing is business challenges obviously there. So everybody has to be adapted with the 5G technology. They have to be good hand in hand with the latest technology. Obviously, it is not only 5G, any technology that we had adapted in the industrial very fast as well, very much important. How much they can adopt the latest technologies. And how the complexity is varying. Obviously, 5G is a very complex method technique, but however, on the when it is growing or when it is coming more and more papers are coming, then it will become more easy to understand. But however, any technology, just like at the beginning, it will be very much complicated. Then the redesign, obviously, everything has to be redesigned in terms of the communication network and everything. As well as for the technical problems, obviously we are not that much familiar with the millimeter wave technology, but now obviously even now it is included in the curriculum, and some of the institutions are included in the curriculum. So it will be like the new generation engineers may be much familiar with the millimeter wave technology and the complexities and the complex terms like facial division multiplexes and beam steering and everything will be familiar. Now it is comes to the development of the product. Now you have to release the product in the market. So as I mentioned before, there has to be compliant. One is any device has to be compliant with the electromagnetic interference and standard as per the IEC and other norms. And also, if you consider about the cables, you have to be compliant with the different kind of CISPA standards. Now, not only that thing, if you consider about your phone, it is radiating, your base station antenna, it is radiating. And 5G, one of the problem with the 5G is the range and the distance between it is very difficult to establish the very large range communication. So one of the thing is there. So for that thing, you need to add a more number of transceivers or routers are there, but that will add more complication, not only in terms of the implementation. The other thing is that how the safety can be affected the people, because generally we calculated the SA, specific absorption rate for the human body for the antenna. Same way for the base station, our performance standard is RIC and RP standard as there. So we have to get that complaints as well. So you have to see that, okay, how much is the particular transceivers are going to get affected, going to affect the human body. That is one of the challenge that also here to be seen. So fortunately, simulation methods, they are also providing you the accurate models, phantom models for the testing, because you know that physical testing is not always possible. Earlier, it was even animal testing was there, but now it is also restricted under certain cases where we can test the animals as well. So that is a good thing that the researchers are implementing the phantom models, which are very accurate and which are very close to the human or animal nature. So it will be easy for you to understand that whether the device is going to be compliant or not compliant. So we will be discussing about three important industry verticals, how the 5G is going to be very much important in that industries. For example, one is high tech, the other one is transportation mobility, and third one is the industrial equipment. For the high tech, as I mentioned, that most of the things are coming on the network side. They will be producing the consumer electronics, or they are working on the smart appliances, or some may be depending on the wireless or wearable antenna network, or it's also applicable for the life science as well, because that is also one of the important beneficiaries of the 5G. So one is the important thing is for us, how we are going to contribute from the electromagnetic point of view. We are going to help them for the analysis or development of the millimeter wave antennas, or how they can integrate that antennas into their particular device. That means and how much that antennas will not going to create any huge amount of radiations, or that will not affect the other issues, because the problem is that generally any antenna that is actually an intentional radiator. And also there will be an unintentional radiator will be their cable. For example, it's an unintentional radiator. So these radiations can affect the other issues as well. So that issue performance will reduce. So we have to find out that is the best shielding method or best isolation method for this antenna. So that is one of the things which we also work along with the industries. And the same way, the development of the 4G, just we did for the 4G, the same thing we do for the 5G. It is more complicated than the 4G network, and the application like a spatial division multiplexes or the kind of beam steering kind of method. So that we are going to implement, we also has to provide the industries a reliable product which is very fast in terms of simulation, because simulation is one of the things. And the problem with the 5G is they have more number of elements will be there and the different kind of configurations. So the simulation should be very fast, and also it should be very much accurate to get the product in time. So we will be not only interested on the antenna design, but the other thing, as I said, when you are going to place the antenna on a particular device. So as I mentioned, that you may affect the devices there. So we have to find out the best isolation for that particular antenna. The other thing is that how that antenna is going to behave in that particular environment. For example, in the mobile phone case, how the radiation pattern is there. Obviously, because of the platform interference, there will be perturbations there. Some perturbations are not applicable, some will be, we can pass that test. So that also we have to be take care of it. So it will be different in terms of 5G in subsea cards or in the millimeter wave, because in subsea cards you already know that the density is more and complication is more, and there will be, because the element size is also large, and to allocate it within the smaller platform is very difficult. But on the other hand, millimeter wave, that element size is very less. But as I mentioned, that we are considering about the antenna array is not just like one or two antennas. When you are considering with the MMO architecture, the one other thing is that how you are going to place it over there on the particular platform, that kind of elements. But they obviously it will be very much short in size. But the range, that is our concern. So that we have to be improved. The other part, as I already mentioned, that the ECU development. ECU development is one of the other key problem. So we needed to understand, we had to smart design the ECUs, which is used for this 5G network. So we had to be that PCB level, we had to make it perfect so that it will not create much problem in the future. For example, the layout, whether that layout will be going to work, or the traces have more cross coupling and all the things we have to test. So signal integrity, power integrity analysis, that is one of the key analysis that's happening in the IA tech industries or 5G industries for to avoid further complications after the fabrication or the testing. So this kind of methods also we have tried. And the other thing is the temperature sensitive, because all the integrated circuits, what we design, it will be all temperature sensitive. We have to find out that how much the temperature is created by this particular ECB, and we have to avoid that heating up the integrated circuit with other devices to be a problem. So we had to find out the solution, and we had to provide the corresponding shading mechanisms or corresponding cooling mechanism for that thing. And finally, after the PCB design, now we had to go to the physical testing. But before the physical testing, we can do the same testing in the virtual platform as well. And I can say that not every software solutions may not be, EMAMC is not that much easily implementable in any software solutions, but most of the commercial softwares are trying to adapt that kind of method. So now you can even go for the EMSA testing like radiated emission, conducted emission, or a susceptibility test. These are very much important. So in 5G as well, there are dedicated testing standards will be there. You have to test it. So physical testing is always cost and time consuming. So you have to avoid multiple testing. So it is one of the best choices. Do the virtual testing and understand that, okay, what are the possible chances of failure. Once you find out that, figure out that thing, you can make the solution here in the software domain itself. Then after that, you can go for the physical testing. So generally you can reduce to 32.7 or something like that. Sometimes you may pass in the first testing, so depending on the standard. After testing and everything, then now once you say that, okay, your device is capable of withstanding any kind of fluctuations and it will work in the real environment, then the other problem is that how the base station or kind of thing is to be implemented the tower, because the implementation the tower is more expensive than the manufacturing of the antenna, right? So you have to be very much careful and all these things. You can then what the virtual platforms like the software simulations can do it. You can virtually place the antennas on the tower kind of structures, and you can provide the electrical tilt and mechanical tilt as per this convenience. You can check that. You can place one or two antennas or antenna arrays. Then you can see that, okay, what is the possible coverage it is happening. So you can understand that thing. You can complete to the propagation mapping and finalize that, okay, for this tower, I needed this antenna in this direction and this electrical and this mechanical. That is actually going to save a lot of time when you're going for the actual implementation. And one more thing is there, you have to go for the compliance as well. So you have to test this particular base station antenna according to as you place a human phantom, and you can test it. Okay, how much is that base station is going to influence the human body, or how much radiation is going to be absorbed by the human body. In sub-regards, the SAS standards is mostly very much important, and the millimeter wave, definitely those standards will need to be there, because the penetration will be less, but the power flow will be have to be seen. So we also tested similar kind of cases, and we have seen that the penetration is very less, but it is actually the power flow is actually happening throughout the body. So that is also one of the thing, and the new standards. So we are waiting for the new standards as well. From the industry verticals, that we didn't provide it, but very soon I hope that the new standards also we are going to be in place, and we're going to test it. And this is an example of what we generally do for the industries, basically for the propagation model mapping and etc. So we have our 3D experience platform where we can construct the entire smart city kind of structures. And what you can do is you can place your base station on the location, just like you can see the base station is placed over there. When that radiation is happening, you can see that, okay, how that radiation is actually spreading across that particular area. And if suppose if your person is over there, you have a mobile phone, you can, it's possible that how much, depending on the mobile phone sensitivity, antenna sensitivity, how much you can receive from that particular base station. So it is a lot of challenges. Obviously, the multipath propagation is one of the things. The weightation is also going to be contributed. What it is missing is obviously the atmospheric effect is not there, but we can include ourselves as the losses. Definitely the 3GPP standard equations will be in place, so we can add that equations as well. We can make more finalized as per the 3GPP standard. Basically, this is one of the important project what we do nowadays, because most of the industries are interested to see that how their base station is going to be working, how efficiently that can be propagated over the media. The other thing is we also do some analysis for the reliability and the resilience as well. For example, in the building, you have a antenna, base station antenna. If a thunder strike is or lightning strike is happening, how much is going to affect at the end? Metallic structure is going to resonate according to that frequency. So it will also going to create a huge amount of current will flow. It can damage the 5G system. So we have to see that, okay, what is a possible effect? We have to provide the appropriate lightning arresters for that thing. And also we can, like you can see it, even we can do the other mechanical aspects also. If it is a wind flowing, or if it is having any earthquake, how much it is going to affect the 5G product and kind of thing. So this all thing is not completely electromagnetic, but there is a mechanical simulation as well. So it is a like complete simulation methodology. So especially I'm going to finish in very soon. So we have to talk something about the transportation mobility, obviously for the automotive industries. So that is one of the major beneficiary of the 5G communication. And nowadays, everybody is interested on the autonomous driver assistance system and the vehicle communication. Obviously, is a smart vehicle. So what are the challenges is going to be faced when you're going to create the most smart vehicle? Like Tesla, they are having a lot of the experiment they are doing. Apple, they are doing the experiments. Obviously, we have to see that how the communication devices are working, because there are so many antennas will be there, so many communication protocols will be implemented for the vehicle. So even after the accidents, how it is, how they are working, how reliable the vehicle equipments, how reliable this electronic modules, that's also had to do. That is a mechanical aspects. And electrical aspects, all these communication antennas will be placed in a small area. So you have to be kept it isolated so that the cross coupling, or what do you say, that the cosine interferences has to be minimized. RF distance should be minimized, and also your cables should be protected from this radiation, because it will be an electric vehicle. Obviously, the electric vehicle, the performance is one of the important thing, depending on the cables and all these things, how they are protected. So these are the one of the bigger challenges in the automotive industry. So we have a lot of customers. They are actually working on the particular aspects. So they are working on the antenna design, placement. Obviously, the ADAS 77.5 gigahertz radar is actually implementing how that performance is there, how accurately it can be working, and they are all doing the testing. And the ghost signal, the presence of ghost signal, they are experimenting. There are so many things are coming. And similar for the smart manufacturing as well in the industrial equipment scenario, the smart beam sensor equipped with the sensors interconnected with antennas. So we already seen that automotive robots, they are actually doing most of the work what you can see here. But how that performance can be improved by using the 5G is one of the example. It's coming from Ericsson and from Hofstra University. So what they did, they have predicted that around 660 million pound can annually save for the bladed disc manufacturing. This actually for the aerospace engine leaf, you can see that it's very the high accurate and precision manufacturing is required for the aerospace engines. So what we can do is we can place that vibration sensors along with the 5G communication device. You can see, you can monitor that how the vibrations affecting. You can make it more and more reliable. You can understand that what are the challenges is going to happen, how it is going to be creating any problems and all these things. This is one of the most important things, and it is the prediction from Ericsson. And the other case is how.
Sumit, just in interest of time, I think if you, how much more do you have?
Yeah, it is going to finish very soon.
Okay, all right.
The similar thing is in the smart manufacturing as well. You can see the pick and place robot over here, and you can place two antennas over there. and each antennas, how the visibility is there, because it is also one of the important things, how many antennas are required to place over to control the kind of devices and everything. So this is also one of the aspect of simulation. So to conclude, what we are seeing is, I just to discuss mostly on the electromagnetic side, but it is a combination of thermal, mechanical, and industrial design as well. So it is like it is all related. So all the devices have a temperature, problems will be there, and because of the temperature can create some mechanical structural problems as well. So it again go back to the electromagnetic performance as well. So all these things are coming into a single nutshell that has to be taken care of it by the industries. So basically, what we are interested is in the electromagnetic and thermal and structural simulations. In all are in hand by handshake. EMAC performance can affect by thermal, thermal by structural, structural by EMAC, like that way. So there are so many projects that we are taking care of it, and we are developing more and more in our 3D experience platform to give confidence to the industries to accelerate the growth in their product manufacturing. So that is a thing which we are only discussing about high tech and transportation mobility in just a short time, because there are so many other aspects as well, life science as well. For example, it is actually benefited by the simulations. So finally, this is what I was presented over here. So anyway, OEM, like you already seen that OEM suppliers, they has to spend a lot of time to invest on the 5G development, and the development to be done, it's to be accelerated. So we focused on the 3 industries, and we have seen that, okay, what is the importance of the simulation over here? So simulation, but obviously I will say that 90% is our effort and 10% is the simulation is coming out, and the 10% is more important for saving a lot of money. That is a sad story. And we, BHARAT 3D is partner with Jasper Systems. We also executed the project we have for the different industries in the 5G. We have certain case studies are there. We that will be available in our booth. So whoever can contact us, can please contact us. We will also ask you, we will also consult you for developing the reliable 5G product in the manufacturing. Thank you very much.
Hey, Sumit, thanks a ton. I think that was a good technical deep dive into all the good stuff that you're doing. So I'm sure the participants or the delegates who are attending found that nice to have. And with this, we have our last speaker of the day. And as I introduced Mr. Shamik Biswas, head of marketing at Printron India, he's going to be talking about how 5G can aid MVNOs in IoT, and his wide experience that he's got doing this good stuff in Africa, I'm sure has some super insights. Over to you, Shamik.
Good afternoon, everyone. I hope I'm loud and clear.
Yeah, you're loud and good. Only the previous speaker's slide needs to end, and if you have a presentation, then that should be put up.
I've already started sharing, I think. 1 second. Is my slides display?
No, we still have the thank you. Now something's happened.
Yes.
Oh, so latency.
It's come, right?
Yes, Shamik. Onek Balo, you are all set to go.
Right. Okay, guys, I am from Printron. I'll tell you a bit about Printron later. But we are present in all 6 continents and one of the MVNO biggies. So these are the insights about 5G and how it affects the industry as a whole and the IoT and the MVNO sector in specific. 5G is the 5th generation mobile network, as we know. It supports connectivity between machines and devices and empowers the device to become the network. 5G facilitates higher data speeds, which theoretically extend up to 1 Gbps, ultra low latency, around 30 milliseconds. Most importantly, it gives more reliability, massive network capacity, increased availability, and which is again more important, and uniform user experience. So it leads into higher performance, improved efficiency, which again leads us into a plethora of new use cases for the end users. the main 5G use cases are ultra reliable low latency, enhanced mobile broadband, and massive machine type communications. Which are the various industries affected by 5G? 5G has a long-lasting impact on manufacturing, energy and utilities sector as a whole, agriculture and even dairy farming, automotive sector in particular, transportation and logistics, healthcare, media and entertainment, and the use case of media and entertainment, that is augmented reality and virtual reality applications. Now, how does 5G facilitate IoT? Here we use the ultra low latency use case of 5G and streamline support for M2M. 5G gives more reliability and efficiency in a number of applications, which include telematics, vehicle tracking with streamlined M2M connectivity, empowers logistic companies like 3PLs and 4PLs. It even empowers delivery vehicles of FMCG, white good, food delivery companies, which lead to a lot of cost saving in terms of fuel and easier reach to customers through various algorithms. It also helps cab companies and aggregators. Connected vehicles, we've already talked about a lot earlier. One of the most important things of connected cars is seamless connectivity to other vehicles, network, infrastructure, and the rest of the ecosystem. We have, for example, done a large connected car implementation for a utility in South America. So there we've seen that data insights and analytics real time can be used to monitor the correct route, and also give patterns of driver behavior and provide preventive maintenance of vehicles. 5G also helps in infotainment because by enabling Wi-Fi in the vehicle, it provides real-time traffic alerts, apart from entertainment, and most importantly, HD video streaming for meetings on the move. So if you're caught in a jam, it helps you in two ways. One, it gives you real-time traffic alerts, so you can predict the time you'll reach your destination. Two, you can get online into meetings. Another major application are telemetry applications. 5G, low power wide area use case enables longer battery life in meters, which is one of the major concerns of meter manufacturers. Also, deployment is fast and cost effective, which is of great concern to various utility providers. We have large telemetry deployments worldwide, and in India, telemetry and smart metering has been widely adopted by most major utilities. There's also faster power reconnection at home, in case of outages with the smart meters. Another application which follows on from telematics is smart grid automation. 5G actually allows us to automate the live electricity grid, incorporate live management, and faults can be predicted or detected, and immediate solutions and preventive maintenance can be given. Another major application of 5G is smart city as a whole. Security cameras, smart city surveillance cameras, which have, video analytics, where anything out of the place will immediately give an alert, quality check cameras, and sensors for intelligent transportation. They can all benefit from the Ultra HD 8K to 4K video streaming capability and the low latency feature of 5G. Smart traffic management is another major tool. 5G enables intelligent transportation as it collects real-time data and alerts from vehicles as well as infrastructure on the roads and gives timely alerts. We've also talked a lot, earlier in this conference about smart manufacturing. Some of the other places where 5G can be used are process automation, predictive analytics for repairs via remote monitoring on production flows, augmented reality repairs, collaborative robotics, which is pretty important in warehouses for picking the right stock SKUs. Precision mining is another major use case of 5G, which can help prevent the wastage of resources. There are also other smart manufacturing use cases like SCADA automation, which can in fact even be used in the utility industry by the feeder trunk unit automation and integration with the SCADA system. Hyper-local delivery is another major use case for 5G. We can use it to enable drones for hyper-local delivery of food by takeaway joints or by e-commerce companies for the last mile delivery. Now, another major application of 5G is in medical applications. 5G can be used for telemedicine consultation due to the high definition 4K to 8K streaming, low latency. 5G connectivity can even empower robotic surgery due to reliable ultra-low latency. Ultra HD video streaming between connected ambulances and the hospital can help monitor patients in transit and also prepare hospitals for treatment so that when the patient arrives, they have all the details. Smart wearables and sensors enabled embedded on humans can also keep constant communication with the physician. Another major application of 5G is smart agriculture and dairy farming applications. IoT sensors across a farm measure in real time data like soil moisture, fertilizer, pesticide, and other chemical levels. They also measure milk yield, livestock yield, and livestock and the entire livestock field as a whole. This use case, in fact, we've used very successfully in one of our South American operations, where we've actually boosted the dairy, the milk production by a multiplier of 10x by effective monitoring. 5G sensors can also monitor agricultural vehicles like tractors and give preventive maintenance. And they can also measure weather data remotely. Data alerts can immediately be provided to the farmers. Some of these alert services are already being provided by current operators like Airtel. But 5G, once it comes in, will actually enable IoT as a whole and be a major boon to the farming and the dairy industry. Now let's come to MVNOs, or mobile virtual network operators, which India calls virtual network operators. 5G deployments allow network slicing. I mean, this is a full 5G. 5G NSA is yet to allow network slicing, is yet to support the network slicing, but full 5G deployments support network slicing, which allows subdivision of a physical layer into multiple network slices. So each slice will have predefined network characteristics or network features with reliable quality of service customized for the segment as required by the specific use case. Hence, 5G network slicing allows differentiated use cases to be offered to MVNOs, allowing segment/use case specific revenue opportunities, most importantly with specific SLAs. So MVNOs do not need to buy the entire physical network, but can actually buy a slice, or if they have several slices, they can offer differentiated features with reliable SLAs. Thus, 5G network slicing provides service flexibility and ability to deliver services faster to different segments with customized features, security, resilience, and ability to meet the contracted quality of service SLA. Hence, this provides a reliable and affordable means of MVNOs to focus on certain use cases. To become more practical and give proper examples, 5G network slicing allows us to tap into different segments with tailored products and also retain control over resources. For example, entertainment MVNOs would be focused on OTT video, streaming, or gaming. These typically require low latency and high speed bandwidth. So they can take a particular slice from the operator and focus on this application with reliable SLAs. Alternatively, if it's an IoT-focused MVNO, they may require specific ultra-low latency for medical applications or connected car automatic applications. There could be the logistics sector where ultra-low latency may not be so important, but streamlined M2M connectivity coupled with AI and some blockchain integration would be more useful. Hence, what 5G network slicing empowers you to do is actually to offer a specific use case tailored for a particular segment like OTT video or IoT MVNO or logistics focused MVNO with reliable SLA for these features, which is a major boon. Now, eMMB, which is also supported by 5G NSA, allows MVNOs to offer differentiated services and applications based on Ultra HD 4K to 8K video streaming, incorporating augmented reality and virtual reality based media, and it gives a 360-degree immersive media experience. So there are profound applications available in the video, entertainment, and gaming sector. This also enables online learning, telemedical consultations, video conferences. Hence, video app-based services can be offered by video conferencing app-based services can be offered by MVNOs independently or in partnership with edtech companies, healthcare, or video conferencing apps, and various startups. Another interesting use case is MVNOs can also live stream local events at stadiums directly or in alliance with local OTTs. This will require both IoT sensor plus 5G, plus it will also require eSIMs to become more popular, though we can do it with the traditional SIM. The benefit of an eSIM is, someone can just go to an event, a local event, which could be a local IPL match or, a local, say, local city league, cricket league, or a football league or kabaddi league. They can just scan a QR code and download an eSIM and have this use case ready. Another major application of 5G would be multiplayer cloud gaming and cloud gaming as a whole. This will be a big opportunity for MVNOs who are focused on gaming and entertainment. And gaming OTTs can also incorporate fully immersive VR and AR, which are suited for 5G technology, and tie up with MVNOs, So the MVNO can have a partner with a specialized gaming OTT, and then the potential and revenue potential and as well as business is tremendous. MVNOs can also partner exclusively with leading global or regional on-stream video OTTs. This will also help the OTTs as they will not be at the mercy of the MNO and its net neutrality. There's a typo here, it should be MNO. Hence, 5G enables 4K to 8K HD video streaming at high speed, low latency, so low buffering. Right? Currently, Netflix or any Z5 or whoever is dependent on the local network of the MNO. But here, with network slicing or whatever, a specialized MVNO can become the last mile partner of the OTT player. And it will be a mutually symbiotic relationship with high potential for both. So this was a brief. In the interest of time, I kept my presentation a bit small. About Plintron, my company. Plintron is the world's largest multi-country end-to-end MVNA and MVNE, and also a CPaaS player offering telco SaaS and TaaS to MNOs, that is mobile network operators, MVNOs, enterprises, and IoT customers. We are operational in 28 plus countries, spanning 6 continents, and supported by 1,000 plus telecom professionals. We have launched 140 plus MVNOs worldwide, have tie-up with 40 plus mobile network operators worldwide, and we have activated more than 150 mobile subscribers for our MVNO customers. We enable any brand to become a MVNO through our complete package. Printron India also is the first unified licensee VNO in India and the 5th national telecom service provider. So this is it. You're always free to contact me for any further details. Thank you.
Hey, Shamik, thank you, Tan. This was just wonderful, the great work that you're doing. And particularly, what one sees is, a major, a very major, let's say, option for integrating and for MVNO operations in India, because, the way the telecom scenario is progressing. So there is a lot of value that MVNOs can bring to telcos out here. And particularly, let's say, for example, a BSNL, right? So all the best, and thank you so much for your presentation.
Thank you.
And I also take this opportunity to thank all the participants and delegates.
Sir, it's muted.
All right, thank you very much. With that, I'd like to hand back to Shashi and the organizers.
Thank you so much. Shami, can you switch off the presentation sharing, please? Yes. Thank you, sir. Thank you so much. Any questions? Did you get, Colonel Saab, any questions on your direct chat?
I don't see anything. No, there are no questions.
The 3-4 questions were there in the morning session. I can still see those questions were there.
I don't know
Ajay,
if
there is any question for this session? Okay. So thank you. So thank you very much, Colonel Vikram Tiwatia, for sharing this session, and thank you to all the panelists. It was interesting session, as the chairman was totally involved with each speaker. That gives a very interactive session. Thank you very much, sir. So we will begin our next session at 2 o'clock. That will be a panel discussion. So thank you very much once again, Colonel Vikram Tiwatia and all the panelists. Thank you so much.
Thanks, Shashi. Bye-bye.
Thank you. Bye-bye. Bye-bye. Bye-bye.